Here we have a problem from the AMC 10 math contest in the year 2006. And it gives us this triangle, which has two circles that are inscribed within it, and they're also tangent to each other, stacked on top of one another. And the bottom circle has radius 2, and the top circle has radius 1. And our goal here is to find the area of the blue triangle. So let's jump into it. First, what I want to do is extend a radius here perpendicular to the tangent point on the triangle for both of these circles. And we'll say that this angle here has 90 degrees because obviously the triangle is tangent to the circle. And these radii are equivalent to the radii outlined in the problem. So this circle has a radius of 1, this circle has a radius of 2. But now, if we extend a line to the top of this triangle like so, all the way through, we can find that this triangle is similar to this triangle because they share an angle here at the top that I'll color in orange. And they also share these angles here. And we know that because the other angle is 90 degrees. Now for a little bit more notation, I'm going to label this circle, circle 1, the smaller one, and this circle, circle 2. The distance from the middle of circle 1 to the point is similar to the distance from circle 2 to the point of this triangle. So I'll go ahead and put that down. That's our first ratio that we're going to be working with. And now we have to compare two other similar sides for these triangles. So let's use our radii here. So we have this radius of 1 for circle 1 or triangle 1, and this radius here of 2. And now you might say that doesn't seem to help us very much, but we can see that the distance from the middle of this point to the point of the triangle is 3 less than the middle of this point to the point of the triangle because we have one radius here of radius 1 and then a radius here that is radius 2. I'm also going to go ahead and label the tip of the triangle point A. So the distance from C2 to A is equal to the distance from C1 to A plus 3. Now I'll go ahead and put this as C1A and C2A here so that we know what we're working with. But that means we have C1A over C1A plus 3 equals 1 over 2. But that means that C1A is equal to 3. So that's really helpful because now we can find the length of A to this point that I'll call B, where the triangle is tangent to the circle 1. So we can find AB by the Pythagorean theorem. So AB squared plus 1 squared is equal to C1A squared, which is 9. But that means AB squared is equal to 8, which means AB is equal to 2 times the square root of 2. And again, that's this length of this small triangle right here. But now we can compare this small triangle that we figured out all the angles for and all the sides for to this large half of the triangle because they share this angle, but they also share a 90-degree angle. The 90-degree angle on the big triangle is right here. And the 90-degree angle on the small triangle is right here, which means this angle also has to be equal to this angle here. So let's clean up this, and then we'll compare this small triangle to this big triangle and try to solve for its area. Okay, so now we're ready to compare these similar triangles. And I've noted that C1A, this length of the triangle here, is 3, and AB, this blue side of this triangle, is 2 times the square root of 2. So what we can do here is we can compare the height of this triangle to the AB over here. So I'll label the middle of this triangle F and this point of the triangle D. So the line segment AF is similar to the line segment AB. And then the line segment FD is similar to the line segment of the radius. So that's just 1. But now from before, we know what AF is because we know that this distance here is 3. And we know that this distance here is 3, and we know that this distance here is 2, which means that AF is 8. So we have 8 over AB, which is 2 times the square root of 2, and then FD over 1, which is just FD. But now, remember this number is also the square root of 8, and so 8 divided by the square root of 8 is just the square root of 8, or 2 times the square root of 2. So FD, this length right here, is equal to 2 times the square root of 2. But now we have a length for half of the base and the height of this triangle. So we have 1/2 base times height is our triangle formula. And 1/2 the base is 2 times the square root of 2. And the height is 8. So our final answer here is 16 times the square root of 2. And that's enough for now.